Good morning, afternoon, or evening, depending on when you're watching this. So we have another guided notes lesson today on factoring. What you guys are going to do is you're going to fill out this guided notes while I go over each problem, and then submit your final guided notes for me to check to see that you one watched the video and two how much you understood from the video. So let's get started. Maria is given a rectangular piece of paper. The length of Maria's piece of paper is represented by 2x minus 6, so an expression, and the width is represented by 3x minus 5. Draw and label a diagram that represents Maria's paper. No problem. So I am able to draw it because I have like a stylus. But for you guys, if you can't, just explain what I did. All right. So first I draw a rectangle, right? And it tells me that the length is 2x minus 6. Length is here. And what I like to do is I like to draw a line down the middle for the operation. So it's going to be negative 6, but we draw it down through the middle there. And then it's 3x minus 5. And for my width, I like to separate it. And then just in between the two terms, I draw a line. All right, now part B. Use your diagram to find the area of Maria's piece of paper. Okay, so 3 times 3 is 6. X times x is x squared. 3x times negative 6 is negative 18x. 2x times negative 5 is negative 10x. And negative 5 times negative 6 is positive 30. Right? So I just took these two, found this one, took this one, and found that one. Right? It's kind of a nice fun thing to do. The only two I have to worry about are these two, right? These are the only two that I have to combine because they're like terms. So my final answer is 6x squared. Negative 10 and negative 18, that's a negative 28x and positive 30. Nice and easy. All right, this is a regions question. So Fred is giving a rectangular piece of paper, very much like the one we just did, right? We just did it, right? It's right up here. Maria, Fred, we can change the name. It means the same thing. So we know that our answer is here. And explain your answer choice, right? We used the area model. Find the product. All right. All right, let's go to our lesson. Our lesson today is to understand that we can represent using the area model, standard form, and factored form. So what do you notice? I notice that there is an extra box here, right? An extra that in our length, in our width, there's no, our widths are the same, but our lengths are a little different. E is a little longer than F, all right? So what do you notice? E is longer than F. All right, that's what I noticed in the diagram. Now they want me to find the standard form and the factored form. All right, so let's do the standard form first for both of them. So I have 2x squareds, right? 1, 2. So I write 2x squared. I have two negative x's, so a negative 2x, and two 3x's. 3 plus 3 is 6, or 2 times 3x is 6x, so plus 6x, and two negative 3's, which is negative 6. So when I combine like terms, I get 2x squared plus 4x minus 6. All right, so that's here. 2x squared plus 4x minus 6. All right, what I'm going to do now is erase so we can do the next problem. All right, so I have two x's here also, right? 1, 2. So 2x squared. I have one negative x, and I have two 3x's, so plus 6x. 2 times 3 is 6. That's how I got 6. Also, 3 plus 3 is 6, right? And then 1 negative 3. So these two are combined like terms. 2x squared plus 5x minus 3. All right, so what do you notice? Let's see. I noticed that my -6 and my -3, because the length for E was doubled, the value of C, right, in the standard form was doubled too, right? So E has a, um, let's see, what else do I notice? That's basically, I noticed that the two x squares are the same, right? So let's do this in a different color for the form. E is longer than F. Standard form has the same leading coefficient, right? So it's important to look at the notice stuff, right, with this math, right? It's important to see the structures there because that'll help you with a deeper understanding so you can do harder and harder topics and problems. All right, let's go on to the factored form. So remember with factored form, when it's x squared and it's an area, that means that this is x and this is x. Why? Because x times x is x squared. And that really helps us with everything else. So what happens here is x squared and 3x, that just becomes 3, right? Because what times x will give you 3x? 3. 3 times x gives you 3x. Okay, this is also x squared. So if this is x and this is x squared, this has to be x up here. And x times what will give you negative x? Oh, and let me just erase this. X times -1, right, will give you negative x. And that also gives you negative x, right? So what's nice about this, now that we have this, we can double check. -1 times 3 is -3. Good. -1 times 3 is -3. Awesome. So now what we do is we just simplify it, and it becomes 2x minus 2 x plus 3. All right. So because we have two x's and two -1s, so a -1 plus a -1 is a -2, right? If I owe you $1 or borrow another dollar, I owe you $2. All right, let's do the next one. So same idea, x. We always start with the x squared. That's easier, right? And here also we can just move this x up here because x times x is x squared. What times x will give you negative x? -1. What times x will give you 3x? 3. And so our factored form is 2x minus 1 and x plus 3. What do we notice? We notice that one of the factors is the same, right? And we notice that also with the widths were the same, so the factor was this, right? So notice how there's a relationship with the picture and also the factored form, right? So we're going to write one factor is the same, right? Because this was similar to this, right? These two are different. And notice here it's -2, and we actually had a second, right? And here it's -1, and we only had a 1, right? So it's interesting to see the relationship there. All right, what does the 2 represent in each diagram? Well, in each diagram, right, the 2 was telling us that it's an area, right? So it's telling us because it's an area, it means squared, right? It means that we have 2 x's, right, when we look at the diagram. What does the 2 represent in each expression? So let's see, the 2 in their expressions, in factored form, it was just telling us that there were 2 x's, right? Leading coefficient, right, is 2, right, for the expression, right? I don't think that, well, in the standard form, it's also, right, the degree, right? So leading coefficient is 2, degree for the standard form is 2, right? Remember, degree is the highest exponent, right? Yeah, so that's it. That's it. Again, just in your guided notes, just if you can't, write out the steps like I did, right? Like I did on here, just write out in words. Now, if you're confused, I suggest going back, watching it, pausing it, writing it down, watching it, pausing it, writing it down, and going really slow, right? This whole, that's why the guided notes part is not too complicated. It's just for you to go over it. If you have to, and you're still not getting it, feel free to reach out. But the goal for this remote learning is that you're able to hit up a bunch of resources, and then we can help you out if you're still confused. But you got to put in the work though, right? That's a big thing for life is you got to put in a little bit of work first, and then if you're still stuck, ask for help. And especially ask for help if you can't even start. If you're if you're feeling like so demoralized, then yeah, don't be afraid to ask for help. All right, one student who was missing diagram E created the following diagram instead. What do you notice? Well, what I noticed is that they broke it up like this, right? I noticed that it's two rectangles, right? So let's see. X, X, -1, X, -1, and 3, right? And this all checks out. It still works, right? In this diagram, is it equivalent to diagram E? So we look up at diagram E, and here's diagram E, and we see it's 2x squared plus 4x minus 6, and 2x minus 2, and x plus 3. So let's see if it's equivalent. So we have, let's first do the standard form. X squared plus x squared is 2x squared. Let's do a different color now. 3, -3, -1, right? So we write plus 3 minus 1 plus 3 minus 1. And when we do that, 3 minus 1 is 2. 3 minus 1 is 2. And we get 4. So far it's looking good, right? So far it's looking the same. And lastly, it's a -3 and a -3, which is a -6. So yeah, this checks out. This is the same. What about here? Well, we have 2 x's here. So yeah, so the standard form is equivalent. Let's see if the factored form is. X plus 3, right? That's the width, right? That's why we just do that. Now we look at the length. X, 2 x's. -1, -1, that's -2. It's the same. So is the diagram equivalent to diagram E? And you are going to write yes. How do you know? The, the equations, and put plural because we checked both, are the same. And you could probably just do it, check to see by only doing one equation to see if it works. But we like to be thorough, so we did two. But when you guys do your problem sets tomorrow, feel free to just just find one of the equations and see if it's the same. So a big part of today's lesson is just this idea that, to factor, right, it's the undo, right? So if it's squared, we start with the x squared first and we say x, right? And then from here, that's how we undo here. So if this is x and this is negative x, what does this have to be? It's really one of my favorite topics in algebra. It really feels like, a board game to me. It's like one of those things I used to do with my family. If you play Sudoku, it's kind of like the same idea of just this reasoning. After finishing the matching activity, Micah found these three cards on the floor. And by the way, tomorrow that's what you're going to do for your problem sets is this matching activity. So he found x plus 2, 2x plus 3, and the standard form he said was x squared minus 5x plus 2, plus 6, sorry. And then the diagram is that. Okay, his partner Zara says these three cards do not belong together. Explain why. So the first thing I'm going to do is I'm going to go to my diagram and I'm going to just, if this is x and this is x squared. If this is x and this is 2, this is 2x, 3x, 6. All right, so 3x plus 6. Do you guys see? Wait, hold on. Sorry. So 3 plus 2 is 5x, but these are both positive, right? This is negative. So that's not the same, right? There's no negative here in the diagram, so that's not the same. Let's see. X plus 3. Do you guys see an x plus 3? X plus 2. I don't see it. So his partner Zara says that these three cards don't belong together. Explain why. Well, the first thing, right, we're going to say is the middle term for the standard form, SF, we'll say standard form, is not the same. All right. Also, if we notice here it's x and here it's 2x. So the leading coefficient in the standard form would have been 2x squared, right? That's what we saw in our problems today, is we saw that these things, right? Here, we'll go up here. Oops, sorry, I went too far. Right, that when we have a 2 here, the leading coefficient becomes 2. It doesn't, it's not a 1. So we're going to also say that, the factored form the leading coefficient is 2. And I'll give you a bonus, okay? If you could find another thing that makes these, not match up, and you can because there's three cards and they have to match up. So if they made a mistake in a diagram and it doesn't match up with the standard form, you could find one more thing. So um, if you want three things, find one more thing that where his partner Zara says they don't belong and explain, right? Describe how you would change the cards above to create a set of three cards that are equivalent. Well, I would, if I were him, I would look for x plus 2 and x plus 3 for the factored form, right? And I'll do this in a different color. First, let me just separate it. For the standard form, oh, I just noticed I made a little like here. It should be an x squared. For the standard form, it should be x squared plus 5x plus 6, right? And that's what I would have looked for when I was looking for my cards, all right? Uh, Fill out your guided notes, uh, send them up. Most of you guys are doing really great with this stuff, and then use it for tomorrow's activity. And if you have any questions, just text me, and I promise you I will get to you. Okay. Hope all are well. Bye.